This is not a video. This is a 3D point cloud model created from a drone flight. If you're a landscape architect, or if you are in the landscape industry, or in the construction industry, if you're still guessing data from Google Earth, or trying to achieve results just downloading information from internet, that's over. In today's video, I am gonna guide you step by step on how you can achieve your own results with pretty much any kind of drone. This can be done by anyone, so stay tuned because you are gonna learn how to do it. My name is Eric, I work for a well-recognized landscape firm and we have been implemented this workflow in real life. It's an excellent solution when you don't want to purchase surveyors because getting topographical information can be very expensive in some scenarios, and sometimes our clients are not willing to pay all the surveys that are required for a good analysis. So relying on Lidar data with a drone is a fantastic solution when you want to progress quick and accurate. That's it, let's get started. And also, I am going to show you how you can create these super high resolution maps, orthogonal maps that are fantastic for analysis. You can use them in your reports, make some overlays with analysis. I'm going to zoom in a little bit so you can appreciate the detail of this orthomosaic map. This is the full area, and as soon as we start zooming in, we can see so much detail on it. I can see these people right here, so if you keep zooming, you can appreciate how far this can go. For doing all of this, I have been using DJI R3S, which is a fantastic solution, with the remote RC2, which is right here. But if I'm honest with you, you can use pretty much any drone. You can use DJI Mini, you can use Neo. The drone doesn't matter. What is important here is the workflow that you're about to learn. To start everything, we need to understand how this works. Basically, you need to fly the drone, and the drone is gonna fly all over your site, and it's gonna capture photographs every certain amount of time to get enough data in order to be processed. And the best way of doing this is programming an automatic mission so the drone can fly by itself, and you just basically need to watch it and wait till everything is done. For doing that, I am using Waypoint map, which is this screen that I have in front, and I'm gonna guide you exactly in how you can use this in your own drone. This is the route that I already created, which basically tells you the fly path that the drone is going to take. So it's starting right here on point 1, then it goes to point 2, then it goes to point 3, point 4, point 5, point 6. But there is some important aspects that you need to know while programming a mission. So I am going to reset this and we're gonna do it all over again together. So the first thing that you need to do is go to Waypoint map and you can create an account and you can start for free. If you're gonna go Pro and you want to use all the Pro features, you can pay for the subscription, but it's not really needed. You can do this with the free version, and that's exactly what I'm gonna show you in this moment. Here we are on Waypoint map, and the first thing that we're going to do is we're gonna find the Angel of the North. Let's go to the Angel of the North right here. So here we are in the Angel of the North. I'm gonna select this tool that says polygon, and I am quickly just draw a shape around the area that we are interested. After I have drawn all the area, we're just gonna click on simple and we're gonna put the quality to 80%. Then we're gonna click on advanced, and I am going to change the speed from 3 meters per second to 3 meters. This is the speed the drone is using for flying, and on altitude it's always good to fly 60 meters above the ground level because this keeps you separated from any tall buildings or people, which is always a health and safety issue that you need to have in consideration. On coverage, this is the distance between paths. For example, let's say that the drone is coming right here and then it's gonna turn left and then it's gonna come back again. So the distance between paths is the distance between this line and the next line that the drone is flying. So when you're flying to 60 meters above the ground, it's always recommended to have a distance between paths of about 15 meters. The line direction legs, this is about the direction of the flying. So if you choose east to west, that means that the drone will be flying from east to west to create all those patterns. If you choose north to south, the drone will be flying from north to south to cover all that shape. But instead, if you use Auto Premium, the drone is gonna set up the most efficient pattern for acquiring all of that data. Some of these settings are only available on the premium membership, but if you want to do it with the free version, just go ahead and click on the settings that are available on the free version, and it's gonna do the job completely. You don't really need the premium version. Then on the image overlap, we're gonna choose 80%, and then on the camera, I'm gonna first choose minus 90 degrees because I want to create this orthomosaic map with a lot of resolution. And then we're gonna do a second flight to capture more data just around the angel right here. So for the first flight, it's just gonna be minus 90. And then we don't need to set up any action because that we're gonna set up in the controller. And then we're just gonna click on generate. So as you can see, this has created all the waypoints. It starts from here and then goes to 2, 3, 4, and all the way around. And then we can save this mission. I already saved it on my account, but I'm gonna save it again. So it's gonna be tutorial angel 1. And then you're gonna save it. It's telling you that the estimated mission time is about 7 minutes with 20 seconds, which is fair enough for a DJI R3S, which gives you 45 minutes of flight. Now we're gonna go again to that tutorial angel 1, and we're gonna open it. And we're gonna create our second path for getting more detail from the angel. So for doing that, I am going to reset the map, clicking on this button right here. And basically it has deleted all the data. And I'm going to create a circle using this POI circle. And I'm gonna start from the center, and I'm just gonna go a little bit further from the wings. For this one, I am going to go to advanced. And I'm gonna let the settings exactly as they are, but for this, the camera is gonna go minus 45 degrees rather than minus 90. So when the camera on the drone is minus 40 degrees, it's getting more detail because it's capturing in an angle. And when you have it minus 90, it's just looking straight forwards to the ground. So for getting more detail around the wings of the angel, let's say that the microphone is the angel. When you have a 45 angle degree, the drone is going to do all of this, and it's going to be able to get more data from the sculpture. After we choose minus 45 degrees, we're going to click on generate, and as you can see, this is giving you the loop. It's telling you that it's going to take 1 minute and 40 seconds, and this is going to be called tutorial angel underscore, and we're going to click OK. And we're gonna create one more third mission, but this third mission is gonna be exactly as this one, but instead of going 60 meters tall, we're gonna go only 30 meters tall, which is gonna give us a little bit of detail from the lower part of the angel. So it's gonna be a reset. Let's draw another circle. It can be probably a bit wider. And on here, we're just gonna change that probably 35 meters. It's gonna work really well. And we're just gonna click on generate. So basically it's giving us the same loop again. And we're gonna call this mission tutorial underscore angel 3. After you have created those missions, the next step that you need to do is to load those missions into your controller. And for doing that, there are different ways you can do it. I'm going to show you the most simple way to do it. It may seem a little bit tedious because you need to connect the controller to your computer through a USB cable. But to be fair, I have been testing different options, and this is the one that has been working for me. I have been using it in professional workflows, and I haven't got an issue at all. There are also another methods of installing an application that is going to do it for you, but in today's video I'm going to show you how you can directly load that mission into your controller. I am gonna press record screen here on the remote of the RC2, and I am gonna start recording this screen so I can show you exactly step by step and how you can do it. I'm gonna go to connect to aircraft, and for now I am just gonna go to camera view. Now I am going to click on this icon right here, waypoint map, and the first thing that we need to do is we need to create a waypoint map from the controller and then replace that file from our waypoint map from the computer. So we're gonna go here in the map. You can be anywhere in the world, it doesn't matter, and you are just gonna create 2 points, for example here, here, here. That would probably take the drone days to do. And now you're just gonna click on this button right here and you're gonna save that mission. And then, because we have 3 files that we need to replace from our computer, we're gonna create 3 more. So I'm gonna create another one. Let's save and exit, and then do waypoint map again and click on this button right here, and then just do another route. Doesn't matter what it is because it's gonna be replaced with our waypoint map file from our computer. Then press here, save and exit, and then we're gonna enter one more time, and this one we're gonna do it somewhere here, 2 points, click again, save and exit. Right, so if we go now to here and then we click on this icon, we can see all the missions that are on the controller. So we're gonna replace these first 3 with the KMS files from waypoint map. For doing that, let's go to the first one, open, and you're gonna press download. So download the file, download this file again, and let's download our 3rd file. Now, let's go to our downloads folder. Now the next step that you need to do is plug the USB into your PC, and then we're gonna create a new I'm gonna put separate this folder right here. I'm gonna put them side by side. I always like to do that because it gives me both screens in the moment. And there you go. Here is the DJI RC2. We're gonna double click on the DJI RC2, which is the controller. Then we're gonna go to the internal shared storage, and then we will go to DJI Go B5. Sorry, data, DJI files, and waypoint. I'm gonna let you this file path on the description of the video so you can use it. Basically, you just need to navigate to the folder of the waypoints, and then we're gonna organize these so we can see that the ones that were modified recently, the ones that are just created with you. And inside each folder, you will find this KMS file, which is the mission created with the controller. So basically we want to replace those files with this file. So the first one, I am gonna cut it from here and I am going to paste it here. And we want to make sure that this new file has the same naming of the original file of the remote, otherwise it wouldn't work. So for doing this, I am going to copy this name and delete that file. We don't need it anymore. It can go away, bye bye. And then this map, paste the name of the other file and enter. So that has replaced that data on the controller. And now let's do it with the other 2. So I'm gonna again cut this file, paste it here. The name from this file is gonna go to that file. So delete that one, we don't need it. Go. And then change the name as the other file. And for the last one is bring this file up to here. Yes, and borrow the name from this file, then delete that file, we don't need it, and replace the name with the other name. So that's it, guys. That's everything that you need to do in this step. After that, you can disconnect your remote, disconnect it, and now I'm gonna show you what has happened on the remote. So I'm gonna start recording again the screen of the remote, and I am going to click on the first one right here after replacing those files. And as you can see, the waypoint map by itself, it automatically adapted to the circles that we did. So once you have done that, we are ready to go to site and fly. Hello guys, we are here on site and we are about to launch our mission. The first step that we need to do is we need to check out that you are in a safe environment and that there is nothing that you can crash. Well, this site is suggested by the GI Fly. It's a perfect site for this tutorial. And we're gonna map the Angel, which is right there behind me, and all this area. We have done our security check. Propels on the drone are fine. It has been calibrated. Memory SD card has enough space. And that's it, let's get it started. We are going to open Waypoint map and then we're gonna select our mission. Once the mission is selected, we're gonna expand the map to see that we have the correct waypoints. And after we are happy with those points, we're just gonna click on the 3 dots to verify the global speed, the camera, what action is going to do the drone after finishing the mission, and make sure that we are starting on the waypoint number 1. After that, we're just gonna set up the camera to shoot photographs every 5 seconds, and once we have done this, we are ready to go. So press go and the aircraft will control by itself. So I already went to site and did this for you guys, and I'm gonna show you now the photographs that we took from that day. It is all of these ones right here. I'm gonna put these into extra large icons, and as you can see, first we started with all the orthomosaic photos that are all of these ones. Basically you can see how it's following the path of the drone. After we capture all the 90 degrees photographs, we went for the loops around the Angel, which is these ones right here. And the next step that we need to do is we need to stitch all these images together to create our point cloud model and our orthomosaic map. So for doing that, I am going to use this website that I have right here that is called Aerial Model, and this is the final result, but I'm going to show you how you can do it. So let's go again to Aerial Model, and on Aerial Model we're going to create a project. So here we are on Aerial Model, and we're going to give a name to our project, and on Select Optimization we're going to select 3D Model Reconstruction Slower. This option is going to give us both the orthomosaic, which is this one right here, and also is going to give us the point cloud model. So that's the option that you want to go for. If you want super high quality on the orthomosaic, you can use the orthomosaic option, but that wouldn't give you the 3D model. So this one gives you both of them and it's very reliable. So choose this one, and after that you just need to select all the bunch of photographs that you took on site. In this case, for this project I have all of these ones, and you're gonna click and open them. I have 451 files, and then I will click on start processing. But this usually can take like probably 3 or 4 hours. So you just need to make sure you have a good connection of internet in the time everything is going up, and then after everything has been uploaded, the site will process it on the background. You can close your computer or shut it down and then check it until it's ready. Usually for 451 files it will take about 6 hours. And we have to remember about the memberships. So you can do this for free, but the maximum photographs that you can take in a model will be 25, and for the ortho project, the image that is like this one, up to 100. In my case, I have the commercial license, which allows me 1000 images per model and 4000 images per orthophoto model. So if you are just learning and experimenting, don't buy anything, just use the free one, see how it works, you don't need to pay for anything. So after the model has been processed, here is the result that we have on aerialmodel.com. It's very detailed. You can go very close and appreciate all the gradients. It lags a little bit and you need to let it load because this is very heavy. It's a model that has 400 and something images, but the quality of this is so impressive. You can rotate it, see from behind. And let's go a little bit here. This wasn't planned on the mission, but the drone also captured some data from that tunnel right here. So I'm gonna try to go there into the road from eye level. As you can see, it's pretty detailed, and we have to remember that this is Lidar data, which means that it's hyper accurate, so you can really rely on this for design options. Of course, if it's for construction, you will need an engineer, but for design stage processes and getting documentation is just the tools that you want to use. Aerial model also gives you different options in how you can visualize this. You can look for topographical elevation, you can use monochrome color, or you can use the normal as well. Also, it lets you to measure inside, for example, angles. It lets you to measure distances. It also lets you to measure areas and many more. We can also set the camera to be from the side, from the front view, or from top view. So the capabilities of this are amazing, but this is still very basic because you need to rely on the platform to watch to see it. And in the next steps, I'm going to show you how you can extract all this data and put it into professional workflows, software industry standards like AutoCAD, Civil 3D Engineer, also Revit, and many more. Once your model has been processed, you can share the link with someone else if you want anyone to look at it on screen. But for now, we're going to download the overhead map, which is the TIFF file, which is right here. In this exercise, I applied a mask on Photoshop to soften all the borders, because in reality it comes like that with all these patchy bits all around. So after you apply a nice mask, you can get this nice product. And we're gonna download the point cloud as well. So let's go ahead and download the point cloud. This is gonna take, like, depending on your internet connection, it's just about 700 megas or something like that. And after you have downloaded the data, it will download like this. You will see 3 folders: EP data, you will see EP hierarchy, EP resources. The next steps is we're gonna look in how we can bring all of that to ReCap, Autodesk ReCap, and then export it to Civil 3D to create the topo contours. So I'm gonna show you how you can bring this to ReCap. It's gonna be called Angel Tutorial ReCap, and then you need to select where you wanna choose to save that project. You click proceed, and here we're gonna select the files to import. And we're gonna click on this APT data. So all of these .las files are the files that you want to bring into ReCap. So basically, you're gonna select Ctrl A, and then you're gonna click open. And basically, it's gonna tell you that you have 1,475 files. And then you're gonna click on import. Now, depending on the type of computer and hardware that you have, is the time that is gonna take. So if you have like a super pro gaming computer or a very high-end CPU, you can expect around 2 or 3, 4 hours to index all of these scans. If you have a more normal computer, it can take more. The more files that you have is the more that it will take. As you can see, the Angel of the North is quite a big site. So I'm expecting this to be finished in like 3 or 4 hours. And finally, after waiting so long, this is our model. I'm being honest, I already processed it before this tutorial, so I didn't need it to wait, but it took like around 6 hours the other day to process. Here it is. As you can see, it's very detailed. You can orbit, you can see the real elevation at this point. It tells you the elevation right here, the real coordinates. So it's a fantastic solution when you want to get precise, hyper accurate data. It's fantastic how you can scroll, how you can navigate, and how you can appreciate this model. ReCap is also a fantastic tool. So I'm gonna guide you through some of the things that you can do. Here on this icon on display settings, you can look by elevation, similar as in aerial model, but this is more professional. Autodesk, it's a very reliable provider. So we can see that our highest point is around 95 meters, somewhere here. We can see the lower points about 65 meters in these areas of the model. And probably we can do a tutorial about ReCap if you want to learn more about what you can do with this software. But our next steps is how we can transform this point cloud model into topo contours and data that we can use in any software. So the first thing that we need to do is to clean a little bit the model, because when we are going to create the terrain, we don't want the terrain to be created with contours that show the height of the angel or the canopy of the trees. So we want to get a smooth terrain. So for doing this, I am going to make a copy, and it's gonna be called, so it's gonna be a save as of this model. And what I'm going to do is I am just gonna clean a little bit the model to delete the points that we don't want in our topo. It took like 2 minutes to make that copy because it's quite heavy. And I am going to start by basically deleting the angel of the north from here and all these kind of tree canopies. So just feel confident to select the points like that, and then just press delete. And scroll a little bit more, look from the other side. We're basically mutilating the sculpture. Anthony Cormy will be mad if he sees we're doing this. Anthony Cormy is the artist of this masterpiece. Let's delete that. And now I'm gonna go to top view right here, and I am gonna go to top view, and here where it says window, I am going to select, and basically this is like a polygonal lasso tool. So I am gonna go all the way around here, and I'm gonna delete all the information that I don't want. I'm gonna select that fence, and I'm gonna go something like this. I don't want the highway to be inner. And now I'm gonna delete those points. Scroll down a little bit here. With fence tool, I am going to select this. Delete those points as well. And from here, I am gonna go back to window, select those, go back to fence again, and let's go something like that. Yes, so our model is looking a bit cleaner now. I'm gonna delete those feet from the angel of the north that I think I didn't delete it before. Somewhere like that. Let's select these ones. Let's see, yeah, we're also deleting those canopies because we want to get only the plain terrain to get super hyper topo contours. Now we're gonna go to top view, and I am gonna get rid of all these trees right here, but letting the other side of the trees. So I am gonna go to fence again, and very carefully I am going to just delete those point clouds occupy the canopies of the trees, somewhere like that, and delete those points because this is where all the trees are. So what Civil is going to do is going to generate the average gradient from this point off to this point and not taking in consideration all those trees. So I'm gonna keep cleaning this model and speed up the camera a little bit. And there we go, guys, we have a clean model. It looks a bit odd at the moment, but this is exactly what civil engineer needs to just get the data of. So we're gonna save this model and we're gonna choose to optimize the model. So the better cleaning that you do, you're gonna get the best results because you want civil engineer only to look at terrain to get precise data. And now we are on civil here. I'm gonna go to XREF. If you don't know anything about XREFs, go and check my tutorial about XREFs. The card is appearing right here where I explain everything about them, why you can use them, how you can use them, why you need to use them, and how they improve all the workflows across the industry. So we're gonna click right here and we're gonna select on attach point cloud. And we're gonna select our super angel coordinates updated _ cleaned model. And then we're gonna just double click on it. We are just gonna click OK because it's gonna come to the right coordinates of the real world model. So just press in and here is the model. So the next step that we're going to do is we're gonna select the point cloud model and we're gonna click here on create surface from point cloud. So click here and here is where the tricky and important bits come. So we're gonna first go to general. We're gonna name the surface as terrain. Angel terrain, and here we're gonna select to have contours every 2 meters and probably 1 meter and 5 meters. to get more detail on the terrain. Then we're gonna go to the point cloud selection, and here on the points we don't want to select all the points because this is gonna just make our computer to crash, and even though you don't need a distance of 3 millimeters between each, so we're gonna tweak the distance between points to, which means that we're gonna get a point every 30 centimeters from the model to get the data. And then on this part we're gonna select Kirkin interpolation, which basically is gonna give us the average in case we don't delete in case there is a shrub or a car or something that we didn't clean from the base. If you select no filters, it's gonna create the contours with everything, and that's what we don't want. We want the topo to be as more accurate as possible regarding the ground level. So we're gonna click on Kirkin interpolation, and then we're just gonna click create surface. Now again, this is gonna take a little bit of time depending on how quick is your computer. In this case, let's hope that it's gonna be done like in 1 or 2 minutes. And let's press close. You can see here that the surface is being created in the background. Civil 3D is gonna send us a notification when this has been completed. So the surface has been created now. You can see how both of them are overlaid now in this. And as you can see, it's very accurate. You can see all the detail in the slopes. You can see all the detail in the roads. This is a fantastic way for getting hyper accurate data. And now I'm going to show you some tricks that you can do with this. I am going to select only this, then get that out, right click, isolate objects, and isolate selected objects, so we can see only the surface that we've been created. Now if you change the viewpoint to isometric, you will be able to see all the mesh that we created, but as soon as you go back to top view, it automatically displays as contours. So here we can see all of our contours, we can see where the high points are, and now I'm gonna put this side by side with our model so we can see where we are. And for doing that, I'm gonna just open the model that is not cleaned so we can look in the screen together. Let's put recap, so let's put them side by side, and let's click top view on recap, top view on civil engineer. You can see how the contours match the elevation. So if you go here to add labels and this arrow right here, and then go surface and then click contours single, then you can start sticking some of the labels. For example, another one here, another one here, and then here on the scale you can change them to be to 200. I think that will be more decent. And let's go again to contour single, and a label there, another label here. And as you can see, this has the real elevation. This has pretty accurate data, and then you can explode all these contours and just bring them into CAD. I'm gonna show you how you can extract them from this surface, but before doing that, we're just gonna I'm gonna show you another way of adding more levels. So if you go here to surface, and then you click contour multiple, you can basically draw a line from this point up to this point, and then press enter, and it's gonna create all the levels in all of those lines, so you know exactly where at what height is each of the contours. This is fantastic because you can create another one here, and then that will give you all of the levels as well. And this is basically our terrain, guys. This is our topo contours that we have created from our point cloud model. Everything started with these guys right here. Then we went to site, we took the photographs, and that's it. This is the workflow that I have been undertaking in the professional industry in the last few months. But there is many ways you can do this. I'm going to show you the way that I've been doing recently. So I'm going to maximize this. I'm going to select my surface, and here where it says extract from surface, I'm going to click on extract objects, and then I'm going to extract the border, I'm going to extract the major contour, and I'm going to extract the minor contour. So click OK, and what is going to happen is that from that surface is going to extract all the contours in polyline as a conventional CAD polyline. And I am going to go to topo, isometric, and now I'm going to be able to see the contours and also all the surface. So I'm going to hide the surface, select the surface, right click, isolate objects, hide selected objects. And now we are only seeing the contours that we need. So I'm gonna basically copy all those contours. I'm gonna press Ctrl C, and then I am going to open AutoCAD, create a new drawing, and then right click, clipboard, paste to original coordinates. So zoom, enter, extend, and what has happened is that we have all those contours here on CAD ready for us to be used wherever we want. Now, this doesn't stop here, guys. The capabilities of these ones are tremendous. In today's exercise, I have been just showing you the top of the iceberg of this, because there is many more things that you can do with this. You can export this civil surface to Revit, you can export it to Rhino. When you export it to Revit, it actually comes as a terrain object inside Revit, which gives you all the capabilities that Revit gives you to keep manipulating that geometry. And after this, it's up to your creativity what you want to do with this. Just as a recap, here are three outputs together. I think they look beautiful all together like they are. Here we have our Orthomosaic that was downloaded directly from the aerial model website. As you can see, it's super detailed. You can zoom in, you can extract things, and just keep working on it. This is our point cloud model that we generated, and this is the topo surface that we created using 3D Civil Engineer. This is all the things that we have been looking today, and I hope this has been helpful for you guys. It's very exciting to see what you can do with these little guys, and just a little bit of your creativity and the tools that are already there. I hope you have learned something. If this tutorial was interesting for you, please let me know in the comment box. I would love to know your opinion. I would love also to know if you have any suggestions in how I can improve these videos and in how we can improve our workflows as well. Any comments is always being received as a positive feedback. And all I can say, if you have made it up to this part of the tutorial, I truly wish you that you have learned lots of things. If you are not subscribed to the channel, please don't forget to subscribe, give me a thumbs up, and I'll catch you next one, guys. It has been a pleasure to guide you through this process. Thanks.